It has for many centuries captured human imagination. From ancient myths and allegories through to modern science fiction, the idea of movement in time has fired endless curiosity and debate. But can time travel ever really occur? Indeed, while theoretical physics leaves many exciting possibilities open, the concept is riddled with restrictions, which makes it both enticing and elusive. Time travel theories mainly originate from Einstein's theory of relativity, which transformed human understanding of space and time. Relativity theory states that time is not absolute. It stretches, compresses, and bends with respect to factors such as speed and gravity. Such theories paved the way for time dilation, whereby time moves at a slower rate for objects that are traveling at speeds close to light. For instance, astronauts in high-speed spacecraft experience time a little differently than people on Earth, a glimpse of real-world evidence for the nature of time travel. But to move forward in time through time dilation is one thing, and it is another to go back in time through traveling backward, visiting the past. One theoretical approach to backward time travel is through wormholes, hypothetical tunnels connecting different points in space-time. According to Einstein's equations, wormholes could, in theory, allow shortcuts through time and space. However, creating or stabilizing a wormhole would require exotic materials with negative energy, which are purely speculative. Even if they existed, wormholes might collapse instantly or be far too unstable for safe passage. Another possibility arises in the concept of closed time-like curves, where time loops could actually form under some conditions. It might be that someone could go back in time and relive events. However, CTCs introduce a myriad of paradoxes. The most famous is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, how could you exist to travel back in the first place? Such paradoxes point to a central limitation of time travel: causality. The universe must run by cause and effect. There must be an action for each reaction. Traveling to the past will dismantle this chain and create contradictions that question the basis of reality. Another limitation is the energy problem. Theoretical models of time travel often involve astronomical amounts of energy. For example, a spaceship approaching the speed of light would require infinite energy, a physical impossibility. Similarly, generating or maintaining a wormhole would demand energy levels far beyond what humanity can currently produce. There's also the question of accessibility. Even if time travel were possible, it might not be practical for visiting specific moments. Many theories suggest that time machines could only transport someone back to the point when the machine was first activated. This would rule out traveling to ancient history or witnessing events predating the machine's creation. Philosophically, time travel challenges our perception of reality itself. The multiverse theory, for example, suggests that changing events in one timeline creates a parallel universe, avoiding paradoxes but complicating the idea of a single history. But it also raises more questions than answers. Would these alternate universes be accessible? Could travelers return to their original timeline? Ethical and societal limitations also come into play. If time travel were possible, it could lead to catastrophic consequences. Imagine the potential misuse of such technology, changing history, stealing knowledge from the future, or creating an imbalance in the natural order. The mere existence of time travel could destabilize societies, economies, and even the universe itself. Despite such challenges, time travel is something that remains tantalizing and theoretically possible in the world of physics. Quantum mechanics, for example, promises the weirdness of quantum entanglement and retrocausality, wherein the effects of a process can influence its cause. Such ideas, though not actually conceived yet, indicate that our perception of time is far from complete. In a nutshell, time travel is an idea that combines science and imagination. The theories of relativity and quantum mechanics open doors to intriguing possibilities, but the practical and philosophical limitations make it a daunting challenge. For now, time travel exists as a thought experiment, an exploration of what might be rather than what is. Whether time travel will ever be possible is unknown, but the pursuit of its secrets continues to inspire scientists and dreamers alike. For after all, Exploring the nature of time itself is a journey worth taking, even if we never leave the present.